Hello, guys. Welcome to a new live stream. Today, I'll be streaming dynamic programming. This is the first live stream of dynamic programming, and let's try to learn how we can solve these problems. Let me share the link first, my stream. Hmm. Where is DP? So here is DP. So initially I've done something. So while in recursion playlist, solved some problems using DP on the live stream. I see I have solved some problems of 1D DP, 2D and 3D DP. Bruh. DP on subsequences. DP on strings is untouched. DP on stocks is untouched. LIS patterns. And then we have matrix change multiplication DP and partition DP. I think we've solved this palindrome partitioning. 2. Oh no, we haven't. We solved palindrome partitioning 1. And then DP on square is just 2 problems. This is a huge playlist. Let's see how many problems we can do. Some of these problems might already be solved on my lead code. So I won't go on from the introduction because that will be too basic. Let's go on to climbing stairs. Alright. How do I hide this, man? Is there... Okay, good. You're climbing stairs. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. How many distinct ways can you climb at the top? N is equal to 2. 2 steps. There are 2 ways to climb to the top. Step 1 plus 1. 2 steps. Either 1 step or 2 steps. So the addition should be total this. Output is 3. So 1 1 1 1 2 2 1. Okay. N can be up to 45. Now how do I think of this as a DP problem? So first of all, how many ways is the first question. So in order to find how many ways, I have two ways. That is, move up by 1 step or move up by 2 steps. So if I start a recursion tree, where is my paint? So this is starting point 0, this ending point n. So every time I have 2 options, I can move 1 step or 2 steps. So total steps are 1, total steps are 2. Let's say this was 5 steps. Okay, then again after 1 I have 2 options, 1 and 2. This becomes 2, this becomes 1 plus 2 3. This is 1 and 2, 3 and 4. This is 1 again, becomes 3. This is 1 again, this becomes 4. This is 1 again, this becomes 5. This is 1 case reached. This will be 2 here. It will become 4. And then 1 here, it will become 5. Another case reached. This is 3. 3 will become 5 directly here by 2. And then 1 and 1. This is another case. And here we'll have 4 and 5. And then here we will have 5 again. So another case. Here we can't move 2 steps, just 1 step. So 5 here, 1. So now what are my ways? 1 1 1 1 1. This is one way. For this, what is it? 1 1 2 1. 1 1 2 1. Similarly here, 1 2 1 1. 1 2 1 1. 1 2 2. 1 2 2. 2 1 1 1. 2 1 1 1. 2 1 2. 2 1 2. And 2 2 1. So these are the distinct ways. 1 2 3 4 5 6 7. Total I'll have 7 ways of doing this. So what if I go and write a recursive code for this first? So what I've observed till now is recursion is only used when I want to trace back, when I have to do backtracking in order to trace my path. Alright, so what if I, instead of using DP here, I'll right away instead of using recursion, I'll right away use DP. So what are the states that are changing? There are 2 states. No, first let me write the recursion function. This is the first question that I'm solving. So recursive function will be define the rec will take an index. Okay, try to ignore that, bro. Define rec will take an index. Exit condition will be if total. These are the total steps that I'm tracking and what index I am. Index is not necessary. I'll be starting from total is equal to 0 and keep on increasing. So if total is equal to 5, if total is greater than or equal to 5, if total is equal to 5, then I'll add ways plus equals 1. There will be a public variable ways. This will be 0 first. Ways first equal to 1. Total is equal to target. Now total is equal to n. Then ways plus equals 1. Otherwise, what I'll have 2 ways. Either go 1 step more, and then I'll call rec total plus 1. Total plus 1. And I'll call rec total plus 2. Total remains same, right? If total plus 2 is less than or equal to n, only then I'll call this and I'll return. And if this doesn't work after passing this, I'll return. I'll call rec for total 0 return and oh, return ways, dumbass. What do you mean not associated with the value? It's right here. Huh? Bro. Bro, what? What's wrong? What's wrong, man? ये कब से होने लग गया भाई? नॉन लोकल वेज. What the fuck? Critical scoping issue with Waze variable. This will throw an error inside. Python treats Waze as a local variable inside this. Since it's defined outside, you can modify it unless you declare it as non-local. Python nested function can read outer variable but can't modify them unless declared non-local or global if outside any function. Okay. I'll just return one. So that is how it works. Now in this, what we did here is if total is m, how do I convert this to dp? So what is changing here? Every time there is just one variable that changes, that is total plus 1. My back hurts. So there is just one variable changing, that is total. So I'll make a dp of size n plus 1. So when total is 0, no, that is not how I read this. So if n is equal to 0 or n is equal to 1, I'll return 1. Okay. Then dp of 0, dp is of length n plus 1, dp of 0 and 1 is 1. Then for n range 2 to forward, dp of I is equal to dp of I minus 1 plus dp of I minus 2. Is that what happens here? So rec of total is total plus 1 and total plus 2. What does it mean? Moving forward by 1. But how? What's the intuition in this? Intuition. Let's copy this. For now I will do this, do this. How is this being done so easily? Think I might take some time in order to solve these easy questions, but I really want to understand what's the intuition in them. Absolutely correct implemented in the bottom of dynamic programming about climbing stairs, LeetCode 70. So given n steps, you can climb 1 step or 2 steps at a time. How many distinct ways can you reach the top? So the code explanation is that my dp is of this and this dpi represents number of ways to reach a particular step. So in order to reach the last step, I need to know how many ways I can reach a particular step before that. So in order to reach one way to be at the bottom, that is do nothing, that is dp of 0, right? And dp of 1 is one way to reach the first step, that is 1. Then dp of 2 will be dp of 0. From I step you can come from I minus 1 step or I minus 2 step. So total ways to reach I is the sum. Oh, okay. So that's how we are thinking here. We are going to the bottom, and bottom case is that I have reached the nth step. So from bottom to up I'm going slowly. So in order to come to this position, what was my last desired position? It was n and n minus 1. So in how many ways can I get to n or n minus 1? That I'll add. That will be my answer. And that will go on computing. But for this, I need a base case. That base case is, where do I start from? I start from dp of 1 and dp of 2. How many ways can I come to dp of 1? One way. How many ways can I come to dp of 2? Two ways. Yeah, then I keep on adding it, keep on finding the next step, and that's how I find the number of ways to do this. Okay, so now I've understood what exactly happens in bottom up. Okay, so going back to the problem, this problem is solved as it is. I don't think you need to submit it. Starting from range 2 to n plus 1 to n, and then returning dp of n. Alright, that was the first problem to be ever solved. Now frog jump. This will also be solved. Good that it's not solved here. I solved it in another language. But we find min cost. Okay, frog jump. So we are given heights and output. Minimum cost is incurred when frog jumps from stair 0 to 1 and 1 to d. Given an integer array height and height I represents the height of ith stair, frog starts to jump first stair and wants to reach to the top. Okay, wants to reach the top from any stair. Either frog has two options, that it can either jump one step or it can either jump 2 steps. Alright, the cost of a jump is absolute difference between the heights between the two stairs. Determine the minimum total cost required for the frog to reach the top. So what does it mean to reach the top? It means that to reach the end, right? So I have to reach this step. So in order to reach, given an integer height I represents the height of ith stair, and frog starts from first stair and want to reach the top. So this is the first stair, then it jumps here, it takes 10, and then it jumps 2, it takes 10 plus 10, 20. So that's the minimum cost. So I have to find the minimum cost here. So can this be done greedily? This can't be done greedily, right? Because if I'm to save 10 steps now, in future I'll have to give 40 steps more. So don't think of this greedily. Let's think of this as a dynamic problem, dynamic approach. Okay, so let's say I am on the top floor. So where did I come from? Either came from second last step or last step, right? So if I came from the second last step, then the difference will be from second last step. If I come, then I will have 20 from 2 steps before I came, then I'll have 10. So if I minimize this right at that moment, will it be useful? No. Think more. You are at first step. So here what I have to think is, what is the minimum cost to reach the last step? So in order to find the minimum cost to reach last step, I need to find the minimum cost to reach each step. So minimum cost to reach the first step itself is 0, because the height is same, right? Okay. Then minimum cost to reach the 30th thing is 10. Minimum cost to reach 48 is either minimum of this to this, or wait, these are the 3 things that I need to see now in order to reach to 40. Anyways, I need 40 minus 30 or 40 minus 20. So minimum of dp of I minus 1 minus dp of I minimum of okay, whatever. So what's the base case here? let's first make a dp array. dp is equal to first what do I write, man? Here placeholders, I'll just write 0 into n plus 1. N is equal to length of heights. Okay. Then in order to come to 0th position, I don't need anything. This I found out. Now for I in range 1, I'll start from 1 to n plus 1. Is that how it works? Yeah. So dp of 1, this is for my understanding, dp of 1 will tell me that in order to come to first position, what was the minimum required. So dp of 1 is equal to minimum of dp minimum of heights at 1 heights of 1 minus heights of 1 minus dp of 0, or heights of 1 minus heights of 0. So dp of 1 will be heights of 1 minus heights of 0, and what? Heights of, let's start from dp of 2. dp of 2, 0, 1, 2 will be minimum of heights of 2 minus heights of 0 and heights of 2 minus heights of 1. So dp of 2 will have 10, dp of 2 will have 10, nah bro, along with this I'll have addition of heights of 0 plus dp of 0. This is the expression. I start from 2 to n minus 1. Instead of 2 I write I, instead of 2 I write I, instead of 0 I write I minus 2, instead of 0 I write I minus 2, instead of 2 I write I, what else? Instead of 1 write I minus 1, instead of 1 I'll write I minus 1. I don't think this is right, but I'll keep on doing this and I'll return dp of n. The fuck have I written? Length of heights is not defined. Did you mean height? Of course I did. List index out of range. How can it go out of range, man? Oh, when it reaches n. Okay. It will be 0 anyways. Your output 0. I think they should give me something closer to my answer. Your output is 20, expected was 40. What went wrong? So for this, the answer was minimum of this comma this. No. Bruh. I'm gonna break my head here. Frog jump problem. Copy this, get right here. Bruh. I was closer. What did I do? DPI. Okay, so we don't need I plus 1. That's one thing. We just need n. And dp of 0 is 0. Starting point I in the range I to n. 1 to n. If I is greater than 1. So first, oh yeah, dp of I. First of all, these guys have the worst coding UI here. The fuck is this? Minimum of, first of all, this should go in absolute. Fuck. Absolute of heights I minus heights I minus 2 plus dp of I minus 2. This will also go in absolute. Plus dp of I minus 1. But the problem here is dp of I minus 1 is empty when I start from 2. So how do I address it? So we need to define dp of 1 also. What is dp of 1? So the closest way to come to 1 is obviously absolute of height, H-I-G-H-T, height of 0 minus height of 1. Yeah, so now if I run this, this runs fine. List index out of range. Great. Look at how cleanly they have done. One step would be dp of I minus 1. The easiest, the least way to come is stored in dp of I minus 1. And from there I'm doing the absolute difference of this and dp of I minus 2 and absolute difference of this if I is greater than 1, else I'll give float of infinity. And then I'm taking minimum of these two steps in the dpi and then returning n y minus 1. Bonus, space optimization. Since dpi only depends on the last two values, you can reduce the space to of 1. Alright, so previous 1, previous 2. So previous and previous 2. Also watch out for how many values do I need from behind. So in that way we can optimize. Previous 0 is 0, 1 is equal to previous plus absolute of heights. So I'll start this from 1, 1 minus 1. If I greater than 1, I'll float of infinity, and then I'll do minimum of 1, 2. And I'll assign it to previous 2 and then I'll return previous. Okay. Fine. Yeah. What do you think? In order to return the path, what do we need? Is it backtracking? I think it is. Let's see. Let's modify to not only return minimum cost but actual cost. So, oh my god. So they are taking minimum. Bottom of dp also maintaining path array to attract the previous stair that will construct the path in reverse from the last stair. The fuck? dp of 0 into n, minimum cost to reach I. Yeah, that I know. Previous I is the previous index we jumped from I to reach. We jumped from to reach I. Okay, so everything will be minus 1. And then cost is equal to this. For one step, dp of I is equal to cost. In order to reach the dp of I, 2 steps if I is greater than 0. Otherwise what will it be? It will be infinity, right? On every step we are no we aren't. If cost 2 is less than dp of I, dp of I is equal to cost 2. Previous of I is equal to I minus 2. So previous of I is equal to I minus 1. We stored everything in this path. So in path we have indexes, right? So reconstruct path from the last index to start. Now in previous we have indexes, last index to start. So I is n minus 1, 1 I is not equal to minus 1. Minus 1 is the reconstruct path dot append I is equal to previous of I, and then we are reversing path. What do you wanna reverse the path, man? Okay, after everything is done we are reversing the path. Okay, space and time complexity is this. Next 2 problems are done. Why have I clicked this if I haven't done it? frog jump with k distances. Minimize cost here. So frog can jump up to k stones at max, right? In this, k is 3. So here, instead of here, I can run a for loop. So similarly, for every index in the list in my array, I have to find the minimum cost that is required in order to come to that particular index. So I'll make a DP array of size n. Okay. So what will my DP of n minus 1 tell me? So DP of n minus 1 will tell me what is the minimum distance that is required to come to that path. Reach the last one. So in order to reach the last one, why does it need 20, man? For the 100, 0, 10, 20. Bruh. Okay, is 1. So at max it can take 1 step. Okay, is 3. At max it can get 3 steps. 1, 2, 3. But here it will take 20 here, 1 step, and then 1, 2, 3. So 1, 2, and 5. Total cost will be this. Okay. DP, in order to come to 0th position, I don't need anything because I'm already at the 0th position, right? So it will be 0. Now for I in range 1 से लेके n तक I have to find the minimum key. So one more thing, what if I think in the way of optimizing my DP space? Instead of n, what if I take I values, k values, just the k values? So my DP of this time I'll have DP of k. Okay, so if DP of k, it will store the last k values. But do I need a DP here? What if I so if you're saving space, every time I pop the first element, I'm moving everything to the back. So instead of DP, what if I take a DQ, which is better? So I'm taking a DQ. So DP is equal to DQ. Now bro, thinking a lot. First try to solve it in a normal way of normal DP. So in order to come to first place, what will I need? I'll take for j in range. What will be my j ranging from? J will range from I will calculate the minimum of k steps behind it, right? For j in range k, how do I find the k points behind I? So it will be j minus I, j minus I, right? J minus I minus 1, I minus 2, I minus 3, right? So I minus j will be my last k points. If I minus j is greater than or equal to 0, only then I will do dp of I is equal to dp of I will be what? The difference in absolute difference between the heights. Absolute difference between the height. No, there's no height here. There's array. Absolute difference between the array at I minus whatever the array it is at I minus j, right? And in order to reach to I minus j, how much did it take me? Plus dp of I minus j. Yeah. So in this way, I'll find this, and then I'll take minimum of this thing with what is already stored in dp of I. So dp of I needs to have a very large value. So this will be float of infinity, float of infinity as the initial value. After doing all these things, let me just return dp of n minus 1. Let use, bro. Why did this taskbar get locked, man? Wow. Let's see if whatever I've done is correct or not. Alright, n is not defined. Good. N is equal to length of array. Now tell me. Fuck you. So n was 3, my output is 50 somehow. Let's say it's 10. Let me do it. So dp of 0 is equal to 0. In order to reach to 10, I don't need anything because I'm already on 10. Now for I in range 1 से लेके n तक, what I'm doing for j in range k, so j will be 0 first, I is 1, so j is 0, I is 1, right? 1 minus 0 is equal to 1. Of course it's greater than or equal to 0. So dp of 1 will be minimum of absolute difference of dp of 1 minus dp of I minus, sorry, 1 minus 0, dp of 0, array of I minus array of I minus j. Bruh, this looks something wrong, man. Array of I minus array of I minus j. This is 0, no? J is 0. Minimum of 0 plus dp of I minus j plus dp of 1. dp of 1 is infinity. No, that's wrong. dp of I minus j. J should start from 1, I guess. Always. Not what I is with itself. True. 1 से लेके k तक. Let's run this now. Still wrong. K plus 1. Wait, where is k? Oh, let's submit this. Let's go. So this was for, this is dp of space complexity of n. Let me try to reduce this to space complexity of k. How do I reduce it to space complexity of k? I only care about the last k values, right? So instead of thinking more, I'll just give it to ChatGPT. I think this will be a DQ approach. Maybe. Optimize to space O of k. And you want to optimize OK instead of O, and let's do that. Oh, I was right, they use a DQ. So we can use a sliding window or circular buffer of size k plus 1. Your current solution maintains a full DP of size n. You compute DP of I only need the last k entries, right? Now from input collection, import DQ. N is equal to length of array. If n is equal to 0, return 0. Initialize a DQ that holds at most k plus 1 entries. So I make a DQ which has just 0 at the end now, from range 1 to n, and I'm taking minimum cost as float infinity. For j in range 1 to minimum of k comma what? Minimum of k comma I plus 1. Cost is equal to minus of j plus absolute. Bro, what's minus of j, man? DP of minus j. What is DP of minus j? Okay, so j from last. DP of minus j plus absolute value of array of I minus array of I minus j, minimum cost, minimum cost, minimum cost. And after this, after solving this, what I do is maintain only k plus 1 values in DP. DP dot append minimum cost. Okay, and if length of DP is greater than k plus 1, why are we taking k plus 1 values, man? Then I'll do dp dot pop left, return dp of minus 1. Alright. Alrighty. Okay, so instead of this dp, I'll include dp as a dq which has currently just one element 0, so I don't need to explicitly mention that first element of dp is 0. Now that I have a dq, I'm doing the same thing here. If I minus j is greater than 0, only then and then what I'm doing here is taking, instead of dp of I, there's nothing at dp of I, right? So for every I range, I'm taking min value. I'll keep it as float of infinity at the start, and then I'll calculate this min value every time as minimum of this, comma minimum of min value. dp of I minus j. Now dp of I minus j is same as dp of minus j, right? Minimum absolute error, this, and this will go on, this will go on, this will go on. So after this goes on for n values, I need to put this minimum value in my dq. So I'll do dp dot append minimum value, and if length of dp is greater than k, I need just the case values, right? If length of dp is greater than k, then I'll do dp dot pop left. Okay, So now I have only k values in the DP, and then after all these things are done, I will return what is the last value in my DQ. DQ is not defined. Bruh. What do you mean DQ is not defined? From collections, import DQ. Wait a minute. Is the time complexity increased? Time taken 1 second. Time complexity of n into k and species of k. Let me know if you like to return the actual part taken. No, n into k. And what was it for before? Oh. Why is it TCN into K worse than normal solution? Also, let's clarify one for all. Oh wait, you can reduce time below of and without further constraint like monotone or greedy properties. Just further with heap sliding minimum windows. I don't think I need that. That is too advanced. So we're done with 3 problems. Let's do house robber. Next problem being maximum sum of non-adjacent DP elements. Finally, cheat code. ये भी सॉल्व किया हुआ है भाई. The fuck? How do I hide this, man? 2 तरीकों से सॉल्व किया ये तो. Anyways, I'll come down and I'll just copy this class solution. I'll comment that also. Let's put this here. And we have a new workspace right here. थोड़ा और नीचे ले लेता हूँ. Good. Rob self nums. Okay, you're a professional robber. यही करना पड़ेगा after visa expires. Planning to rob houses along a street. Each house has a certain amount of money stashed. Oh yeah. The only constant stopping you is from robbing each of them is that adjacent houses have security systems connected to automatically contact the police if you have 2 adjacent houses were broken into the same night. Get an integer array nums representing the amount of money of each house. Return the maximum amount of money you can rob tonight without alerting the police. So I'll rob house 1. Money is 1. Then rob house 3. Money is 3. So 4. In this, I'll rob house 1. Then I'll rob house 3. Then I'll rob house 5. What? The fuck, bro? What's in this, man? Do I just need to some alternate and provide them back? Is there some catch here? So there are two ways, either 1 to 1 to 1 rest, otherwise this and this. So I have to find maximum of this alternating things. Bro, so in order to do this, for I in range, let me do this by summation of odd and even elements and returning the max of them. For in range n, for in range length of nums, for in range length of nums, if I modulo 2 is equal to 0, what does that mean? Is equal to 1, that means it's odd. So in odd case, I'll do odd sum plus equals 1 plus equals nums of I, else I'll do even sum plus equals nums of I, and then I'll return minimum of odd sum comma even sum. What about these two? Before running the loop, I'll set them as 0, 0. Well, is this the question that they aren't? Bruh. Two, 3. How is the output 4 here? Okay, I select this. I skip these two answers and select this. That's the catch here. वही बोल रहा हूँ, how can the medium problem be so easy? So is this a greedy problem, first of all? So in order to consider this, I have to consider this. So dp of 0 is 2. In order to consider this, I'll consider this. So these two are same as it is. In order to consider this, I have only one option of considering this. In order to consider this, I have option of considering this and this. So 2 plus 1, 3. Option of considering ये छोड़ के dp of this and dp of this. So can I consider till a given point? How many I can consider? Till 2, till 1 I can consider 0. Till 1 the max I can get is 2. The maximum till before this is 2. Okay, so this will be okay. नहीं हो रहा. What the fuck is this? I think I'll have to watch a video for this. What is this, bro? Previous and previous 2 for I in range 1 to n. with index is equal to nums of I. I'm considering with index if I is greater than 0 with index plus equal to previous 2. Previous 2 is equal to previous, and without is equal to previous. Previous is equal to max of with index and without return previous. Fuck. घर का चोर, घमर का चोमर. Is this house robber too, or is it the same? Oh, it is house robber too. Solve this also. Solve this in C++. Very nice. Ghumad. So, coming back to house robber 1 with the failed as. Don't ever write this shit. You're a professional house. So, let's think about this with a clear mind. Mm-hmm. 1 2 3 1. 1 2 3 1. Okay. So let's take something that we are remembering. This is a DP array. So this is not a greedy solution. So if it is not a greedy solution, it is a DP solution. Wonderful. So till this index, of course it will be same. Till the second index also I'll write the same because we don't want adjacent. Now the real game begins from index, from this index right here. 1 2 3. Okay. So what do I exactly want? So if I want to reach to this, so if I'm considering this position, then the maximum sum that I can get is this. To reach a particular position, the maximum sum I can get. So if I want this position, the maximum sum I can get is by considering this 3 plus 1, that is 4. In order to get to this position, the maximum sum I can get here is 1 plus 2 is 3. In sum I can get is 5 and 5 and maximum of this 2. It can be either 5 plus, either it can be array of I plus dp of I minus 2 max, or dp of I minus 1. Is it correct? Let's see. Bruh. Anyways, dp array of range, let me take length of nums, n is equal to length of nums, dp is equal to 0 into n. What am I taking? Max, so it should be 0. Okay, we are maximizing the profit, so I'll keep initial value as 0. I run a loop for I in range. Where does it start from? It starts from 0 1 2. Actually it starts from 2 to n. Then dp of 0. Let me see the constraints. Number lengths can be between 1 and 0. So dp of 0 is equal to nums of 0. This is fixed. If length of, if n is equal to 1, return dp of 0. Or I can just do this before doing anything else, right? find the length, then see if it is the base case. Okay, now if it is more than this, I'll get here dp of 1 is equal to nums of 1. This two are done. Now I'll start a range loop from this 2 to n. Yeah, so dp of I here will be maximum of whatever is, what did I figure out here? dp of I is maximum of dp of either taking the previous index sum or taking the current element nums of I plus dp of I minus 2. Okay, and I'll keep on doing this, and in the end I'll return dp of n minus 1. Everything's commented. Oh, let's go. Let's see if it runs. Output is 1, expected is 2. Bruh, how did this fucking fail, man? Just because there were two test cases, two elements here in this. So what if I need one more test case. If n is equal to 2, then I'll return max of nums of 0 comma nums of 1. Yeah, this should do. This should cover the one test case that was failing, and you can pass the rest. Fuck, how? Okay, so at this point dp will be maximum of 1 plus 2 3, or maximum of 1 3 plus 1. So at this point it will be 3, and then at this point it was 1. So this is dp of this is 3, this is 1. So considering 2, what will be my output? Maximum of 3 or 2 plus 1 3. So that gave me 3, but the actual answer is selecting this and selecting this. Okay, so that means that my answer is wrong. And how much time? Let's copy this, get to ChatGPT. I'm not stretching my brain anymore. This is classic house robber, perfect for dynamic programming. The core DP idea, let's define the maximum money you can rob from house 0 to house I. Okay, perfect. How do I find this? At every house you have two options. You add nums of I to dp of I minus 2 since you skip adjacent, or take dp of I minus 1, best up to previous one. Alright, now the transition. Oh, dp of, wait a minute, I've written the exact same code here. dp of max of dp of I minus 1, dp of I minus 2 plus nums of I. Python code for bottom of dp. Bruh, no way if this works. I might have to check my solution then. I don't think this will work. What the? What did I do wrong, man? If n is equal to 0, return 0. If n is equal to 1, return nums of 1. And then, oh, dp of 0. Oh, Just one thing was wrong here. The solution was correct in my case, but one thing was wrong here. The initialization of my DP. So I wrote if n is equal to return max of this. Instead of that, I should have done this thing right here. DP of 1 was max of numbers. So now if I run this, it will run. Now in order to optimize this, what's happening here? This is previous nums of 0. Let me take DP of this will be previous 1. This is previous 2. Previous 2. The fuck? Previous 2 and this is previous 1. This is latest one and this is the previous one. Okay, for in range to command, this is the current previous one. I'll store temp is equal to previous one, and I'll change the value of previous one to previous one will be max of dp of I minus 1. Oh, current will be max of dp of previous one. Dp of I minus 1 is previous one. Previous 1 nums plus previous 2. Previous 2, right? And now after this, after I calculate this, what happens is my previous 1 becomes previous 2. Previous 1 is equal to previous 2. And what will happen to previous 2? No, previous 2 becomes previous 1. Previous 2 becomes previous 1. And previous 1 becomes current that we found here. Do I need this temp? No, I don't go. And then after everything happens, what do I need? I just need previous 1. Do I need DP? No. Let's run this. Let's go. This is even better version. Yeah. So in this way, now let's see what I've done here. I've called a recursion self index nums dp. No need to put dp here, no need to put nums here. DP will keep on updating itself. The only thing that we need is index here. So there is just one parameter that is changing. If index is 0, return nums of 0. Index is less than 0, return 0. If dp of index is not equal to minus 1, then return of dp of index, that is dp of index already calculated with index nums of int and then self of recursion index minus 2 nums of dp without index. Alright, whatever. So this is done. Now house robber 2. Let me change it to Python 3. I haven't solved it here yet. This is the last question that I'll be doing now on this stream. House robber 2. What is this robber doing? You're a professional robber. Yes. Plan to rob houses along a street. Each house in certain amount of money stashed. All houses are placed in and arranged in circles. That means the first house is at the neighbor of the last one. Meanwhile, adjacent houses have a security system. They automatically contact the police if two adjacent houses are broken into the same night. Okay, so the only catch here is first and last house are connected. So I think I can do the same thing that I did in the previous question, right? Let me use something. House robber 2. House robber. This is the code that I wrote for house robber, right? I'll copy this. I copy and paste this here. Okay. The only change that I'll do is at the end of nums, I'll append nums dot append nums of 0. So instead of 2 3 2, it will have 2 in the end. I think this should, when I run this, let's see what happens. Tung 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 tung. Tung 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 tung. Wrong answer, wrong answer, wrong answer. So there will be two options, either 2 3 1 1 or 1 2 3 1. These are the two nums that I'll be having. Nums dot append 0. Wait a minute. I'll make two new arrays. I'll make this a different function. Define max robbery. It will take something and it will do something. Okay, max robbery will take what? It will take nums. Nums. Okay, it will take nums and do the same thing that it did. This is the previous function, and for this function now I'll make two new nums. First one is nums1. Nums1 is equal to nums starting from the first element, and then I'll add nums of 0, whereas nums2 is equal to nums of 0, nums of -1 plus nums of what? So here we are skipping the last element. Okay, till what the till -1. Return maximum that I'll get from max robbery given to nums1, comma max robbery given to nums2. Can only concatenate. But what? Why do you care? Try to extend it. Bro, but that's changing the nums1, right? So what do I do here? expand. 3, 2, 1, go. Bro, what? Circular version. Clearly working on, yes. Hazara inserts, and you can't drop the first. You can't drop both the first and last houses. Good. Back to stream. Okay, houses are maximize the loot. Your strategy good thing. You're trying to run Magna to exclude the first. The minor issues in these two lines slightly off. This adds the first house back. Oh, wait a minute. Okay, also includes both ends. Re-including first and last again. This slice. Oh my god. So instead of creating this new houses, I should have just done nums from first to the end, and then this two just till everything except the last one. So when length is 1, I haven't explicitly mentioned it, I guess. So all these things, okay, should be outside here. bruh. If length is 1, then return nums of 0. If length is 2, what will happen? I'll take here I'll put n, and also everything remains same here as it is. Instead of solving the length, I'll put this thing here, and is equal to length of nums, and while passing them to this, I'll just pass in n minus 1. Here I'll pass in n minus 1. Let's try to run this. I guess when two elements are there, what will happen? Okay, this got solved. Let's see what I did in C++. Okay, it's the same. If I is not equal to 0, temp dot push back nums. The fuck? Okay. Turn back. Oh, it's the same. Just that in C++ I had to do a lot of things, which I don't have to do in Python, of course. So we've solved like almost 5 problems today on DP. So one DP is done. There are a lot of DP problems here. Ninja training and all. So now I've got a basic idea of how to directly approach the DP solutions without jumping into recursion. Okay. So that is it for today, guys. Today we didn't solve any new problem, I guess. So it's just 193. Oh, it's still 193. I guess I just solved one new problem in LeetCode today. So anyways, now in next part I'll try to solve this 2D DP problems, and then we have DP on subsequences, LIS, MCM, squares. Good. Thank you for watching, guys. Bye. Let's check if anybody is there on stream. Of course not. Nice.